Welcome back to Bazai. Today's explainer walks through Apache Kafka end-to-end, how producers write, how brokers store and replicate, how partitions scale throughput, and how consumer groups share the work. Use this as a mental model for sizing clusters, structuring topics, and debugging lag. Producers and topics. Producers, web apps, mobile apps, IoT devices, and log pipelines send records to topics. A topic is a named feed, like orders or clicks. Each topic is split into partitions, append-only logs that scale horizontally. A producer chooses a partition based on a key, a custom partitioner, or round-robin. The key guarantees order within that partition, critical for sequences like payments or inventory adjustments. Brokers and storage. Brokers are the Kafka servers that store and serve data. A cluster typically has 3 or more brokers. Each partition lives on one broker as the leader and on others as followers for replication. Producers write to the leader, followers replicate for durability. Segment files on disk make retention efficient. Kafka trims by time or size and can compact keyed topics to keep only the latest value per key. This design turns Kafka into a durable, high-throughput commit log. Controllers and KRaft. Modern Kafka uses KRaft, the built-in Raft-based controller quorum, to coordinate metadata, elect leaders, and keep the cluster consistent without Zookeeper. If a broker fails, the controller promotes an in-sync follower to leader. This automatic failover keeps producers and consumers flowing with minimal disruption. Consumers and groups. Consumers pull records from partitions. A consumer group is a set of consumers that share a topic's partitions among themselves. One partition is processed by only one consumer in the group at a time. This gives horizontal scalability with ordering guarantees per partition. Offsets checkpoint progress. If a consumer dies, its partitions reassign to another group member and processing resumes. Multiple groups can read the same topic independently. Analytics, fraud detection, and indexing can fan out from the same data stream. Throughput and ordering. More partitions, more parallelism, and higher throughput, but ordering remains only within each partition. Keyed events that must remain ordered should use the same partition key. Idempotent producers and exactly once semantics with transactional writes reduce duplicates across retries and failures. Kafka is a distributed commit log. Producers append to partition topics, brokers replicate and serve data, KRaft coordinates the cluster, and consumer groups scale processing safely. Design the partitioning and keys around ordering needs, and let groups handle the parallelism. If this helped, like and subscribe to Bazai, and drop a comment with the current partition and replication strategy and what throughput targets are being chased.